A black background with white writing that says Georgia and Kat's accessible audio-described science videos with an exclamation mark at the end of the sentence. The words Physics Cool Practical 1, Newton's second law are under it.
Hello and welcome to our accessible audio-described science videos. I'm Kat.
And I'm Georgia.
Today we are going to be investigating Newton's second law by looking at the relationship between force, mass and acceleration.
On the screen there is lots of equipment which is on a table, including a ramp and 3 toy cars. There is also some scales, but these aren't the scales that we are going to use for when we are going to do the experiment, because we are going to use some accessible talking scales instead.
The first thing that we need to do is set up the ramp. We will set this up at an angle so that the cars will go down by themselves, because we don't want to have to add additional force that we can't measure by having to push them.
There is now a video that is on the screen of us setting up the ramp, which is a rectangular piece of white wood, by adding 1 wooden block at a time, and we are putting a red car at the top of the ramp to find out if it will go down. The top of the ramp is getting higher each time until the car finally goes down at a good speed. We have put 2 blocks under the ramp.
Now we're going to use some accessible talking scales to weigh each car. I've drawn a results table with a column that is for the mass in grams, with a second column that is for the time taken to go down the ramp in seconds. That column is split into 1, 2, 3 and average, so that we have got space for when we repeat the experiment. We will record the results each time and the table will come onto the screen. When we get some results, we will complete the table.
We are now placing the first car onto the scales. It is a wooden red car with black wheels with silver circles inside of them.
28 grams.
We are now going to write 28 into the first column, and we don't need to write that it is in grams because it already says that at the top of the column.
The second car is a green van that has got the same wheels as the red car.
32 grams.
We are writing 32 in the next space that is in the table.
And the third car is a truck that has got a crane that is on the top of it. It has got the same wheels as the other 2 cars.
55 grams.
We add 55 to the last space in the mass column.
The picture that is of all of the equipment is back on the screen again.
The independent variable in this experiment is the mass of the car, which we are changing by increasing the weight of the car each time. The dependent variable that we are measuring is the time that it takes for the car to get to the bottom of the ramp, which we can then use to calculate the acceleration. And the control variables that we keep the same are the same ramp and the same angle of it, and the same cars that have got the same type of wheels, which will reduce the variation due to friction. We are now going to put the red car, which is the smallest, at the top of the ramp.
The red car is now at the top of the ramp, and there is a stopwatch that is on a phone, which is also on the screen. When we let the car go, it goes down the ramp by itself. A screenshot of the stopwatch comes onto the screen, which is showing the time that it took for the car to go down the ramp. That is 1.01 seconds. This will come onto the screen for each time that we are going to repeat the experiment, before we will add the results into the second column that is in the table. We repeat it 2 more times with the same car. The second time that the car went down the ramp was 0.95 seconds, and the third time that the car went down the ramp was 1.08 seconds. We then do this with the green van, and the 3 results that are from it are 1.02 seconds, 0.95 seconds, and 1.03 seconds. We then place the truck at the top of the ramp, and the 3 times that are for how long that it took for the truck to go down the ramp are 2.32 seconds, 1.94 seconds, and 2.27 seconds.
In the average column, we are now going to write down the average time that each car has taken to go down the ramp. We are going to add the three numbers that are for each car, and then we are going to divide them by how many times each car went down the ramp, which is 3 times.
We are adding 3 numbers to 3 columns that are for each car. The average times were 1.01 seconds, 1.00 seconds, and 2.18 seconds.
Now we know how long it took for each car to go down the ramp, we need to work out the acceleration. To do that, we need to know the speed. The equation for speed equals distance in metres divided by time in seconds. We have measured the ramp, which is 0.38 metres.
The equation that is for speed is on the screen in a blue box. It says speed, and then in brackets it says m/s, which is for metres per second, and it equals distance with a letter m in brackets, that is for metres, divided by time, that has got letter s, that is in brackets, that is for seconds.
I have added a column to the table that says average speed in metres per second. Now we're going to calculate the speed that is for all of the cars so that we can add it to the table.
We are adding the numbers that are for the average speeds that are for each of the cars into the column. The numbers are 0.38 metres per second, 0.38 metres per second, and 0.17 metres per second. The equation that is for acceleration is now on the screen. The equation is acceleration equals change in velocity divided by change in time.
We can now work out the acceleration with this equation, so we can add it to a new column that is in the table called acceleration.
We have written the numbers 0.38 metres per second squared, 0.38 metres per second squared, and 0.08 metres per second squared into the column that is for acceleration.
We are now going to plot the graph of acceleration against mass to show the relationship between them.
On the screen you can now see graph paper, which is paper with tiny squares on it. Every fifth square, horizontally and vertically, has a line that is darker. A hand is drawing the vertical y-axis and adding numbers 0 to 0.4, going up in 0.1. They label acceleration in metres per second squared. The horizontal x-axis is labelled mass in grams and also has numbers that are added to it from 0 to 60, going up in tens. We are putting a cross at each result, first at 28 and 0.38, then 32 and 0.38, and lastly at 55 and 0.08.
Once we have drawn the graph, we will need to draw a line of best fit to show the relationship between acceleration and mass. This line of best fit fits the plotted dots, starts at the top and curves down to the bottom right-hand side of the graph. It can be a straight line or a curve. In this case, it's a curve. This experiment shows us that mass and acceleration have an inverse relationship, which proves Newton's second law, which is that force divided by mass equals acceleration.
We hope that you have found this video accessible and interesting.
Please feel free to leave us a comment.
And don't forget to subscribe for more accessible content.